Hi, in this video I am going to explain what is LED, how it will work, what type of material is used and their advantage, disadvantage, applications and comparison of this LED with some other light sources. LED, light emitting diode, is a PN junction diode which emits light when forward biased, and it never emits light when reverse biased. LED is essentially a PN junction opto semiconductor that emits a monochromatic light when operated in a forward bias condition. Monochromatic means single color. That light emitted from the LED in a single color, but you can see this LED colors in different ways. That is determined by the material used within the LED. LEDs convert the electrical energy into the light energy. They are frequently used as pilot lights in electronic appliances to indicate whether the circuit is closed or not. If the circuit is closed, the LED will glow. If not, LED does not glow. So like that you can conclude the presence of supply with the help of the LED. In all semiconductors, some of the energy will be radiated as heat and some of them in the form of photon. Photon means light. In silicon and germanium, large energy is radiated as heat and very small energy is radiated in the form of photons. But in materials like gallium phosphide, gallium arsenide, like the specific materials are there, in that energy liberated in the form of photons is sufficient to create a visible light source. That concept is used in the LED. In the given diagram, you can see the different wavelength of light. The different wavelength of light that determines the colors. In ultraviolet wavelength ranges from 100 to 400 nanometers. And visible range is from 380 to 770 nanometer. The visible range, if the light is emitted, means we can see that colors. And next spectrum will be the infrared. That is beyond 770 nanometers. We will be having a wavelength spectrum for the infrared rays. So this wavelength determined by the energy gap of the material that can be used within the LED. In case of normal diode also that emits the light, but we cannot see that light, that is it is lies in the invisible range, but we can feel the heat effect. Next we'll see the symbolic representation and forward bias condition of the LED. In symbolic representation you have two terminals that are anode and cathode, and have a PN junction, and over the PN junction there is a arrows that indicates the emitted light from the LED. And the forward bias condition, LED will work. What is a forward bias means? From the battery, if the positive terminal is connected to the P type of semiconductor and the negative terminal of the battery is connected to the N side of semiconductor, means we can say that condition is forward bias. And already I said under the forward bias conditions, LED emits lights, so that will be represented as the arrows. Now you can see the structure of the LED. LED consists of PN diode and two electrodes. PN diode represented as a LED chip, and the two electrodes are represented as a cathode and a anode. Usually the longer terminal will be the anode and shorter terminal will be the cathode. And This PN junction is surrounded by a transparent plastic case to protect the diode from external shock, that is of epoxy resin. So this is the outer cover that protect the LED. And if you see the next diagram, we can understand the structure of the LED. Here an N-type layer is grown on a substrate and a P-type is deposited on it by diffusion. So first layer will be the N layer, then P layer is deposited over the N layer by diffusion process. Since carrier recombination takes place in the P layer, that is in the valence band, it is kept uppermost. The metal anode connections are made at the outer edges of the P layer so as to allow more central surface area for the light to escape to the outside. LEDs are manufactured with the doomed lenses in order to reduce the reabsorption problem. A metal gold film is applied to the bottom of the substrate for reflecting as much light as possible to the surface of the device and also to provide the cathode connection. That is, bottom portion acts as the cathode. It will be coated with the gold film so that will reflect the photons and it does not allow the photons escape at the bottom side. It allows more and more photons to the uppermost part, that is from the P layer emitted in the form of light. So this is the structure of the LED. Next we'll see the materials used in LED. If gallium arsenide is used in the LED, we will be getting a infrared light, that is invisible light. At the same time, gallium arsenide phosphide, if used to manufacture the LED, means in that case we will be getting red or yellow light. And if you use gallium phosphide alone, means you can able to get the green and red light. Suppose if you want a blue light, means in that case use the material as a gallium nitrate or gallium indium nitrate. And this material selection determines the colors. So it must have an energy gap of appropriate width. The energy gap determines the wavelength of light. So, and the material selection should be such a way that it must have an energy gap of appropriate width. And both N and P type must exist with low resistivity. And efficient radiative path must present. Like that you have to select the material to manufacture the LED. Now I'll see how LED will work. When current flows across a diode, that is under forward bias, negative electrons move one way and positive holes move the other way. The holes exit at a lower energy level than the free electrons. In this diagram, holes are represented by the white color, electrons are represented with the black color dots. Therefore, when free electrons falls, it loses energy. This energy is emitted in the form of photons. In this diagram, represented as a red arrows, photons, which cause light from active region. They are represented as a pink layer. The color of the light is radiated by the fall of the electron and hence energy level of the photon. Usually the color of the light emitted will be determined by the material that will be used within this LED. Now we'll discuss what is the speciality of LED. When LED is forward bias, current flows through the diode. Holes are injected by positive terminal and attracted by negative terminal. Electrons are injected by negative terminal and attracted by positive terminal. During this process of flow of electrons and holes, there will be a recombination among them. As a result of recombination, the electrons lying in the conduction band of N region, shown in the diagram, falls into the holes lying in the valence band of P region, as shown in the diagram. The difference of electron between the conduction band and the valence band is radiated in the form of light energy. That is, jumping of electrons from conduction band to the valence band is liberated in the form of light. Each recombination causes radiation of light energy. Light is generated by recombination of electrons and holes, whereby the excess energy is transferred to an emitted photon. The brightness of the emitted light is directly proportional to the forward bias current. So if we increase the forward current, we will be getting more and more photons. In normal silicon and germanium semiconductors, this entire radiation of electromagnetic wave during recombination is in the form of infrared radiation. That's why we cannot see the light in the case of PN diode. The wavelength of the infrared are out of our visible range. Infrared electromagnetic radiation is nothing but heat that we can feel but we cannot see. This is because silicon and germanium semiconductor are not direct gap semiconductor. Rather, these are indirect gap semiconductors. What happens in the indirect gap semiconductor is the minimum energy level of conduction band and the maximum energy level of the valence band do not occur at the same momentum of electron. Both the levels will be at the different. But in the case of direct gap semiconductors, minimum energy level of conduction band and the maximum energy level of valence band are at the same level. So no chance of momentum of electron when electron migrate from conduction band to the valence band. Like that, photons released when electrons jump from conduction band to valence band, like light liberated. From the previous discussion, we conclude that the fall of free electron from conduction band to the valence band is radiated in the form of photons. So that we can explain through the mathematical relation as follows. Energy of photon, that is equal to frequency of electromagnetic radiation into Planck constant, where h is the Planck constant and f is the frequency of electromagnetic radiation, and Eg is the energy gap between the conduction band and the valence band. So Eg is proportional to the frequency of electromagnetic radiation. So the energy gap of the particular material determine the emitted light. Usually the velocity of electromagnetic radiation is constant, the speed of light is constant. So we can relate this energy gap to Eg as hc divided by lambda, where lambda is the wavelength, h constant. So only thing, this energy gap depends upon the wavelength of the light. So the energy gap down determines the wavelength of light, thereby we will be getting a particular light. Characteristics of LED. You can see that this curve is similar to the characteristics of PN diode, since both are made up of semiconducting material. After some current voltage, it starts conducting. If you see the VA characteristics, and if you see the output characteristic curve, that is radiated power is proportional to the forward current. So if the forward current increases, the corresponding increase in radiated power can experience in the LED. The next we'll see the certain features of the LED and that are the advantages of the LED also. That is this curve, characteristic curve of LED is similar to the PN junction diode that already explained, and the operating voltage will be from 1.4 volt and 3.6 volt, and reverse breakdown voltage will be minus 3 volt and minus 10 volt, and that current forward current rating will be very less, that is of 100 milliamps or even less. And the one thing is important in LED, that is for protection of LED you have to connect one series resistance to the LED that ranges from 1 kilo ohm or 1.5 kilo ohm. And already explained that under forward bias condition only it can emit the light. If you reverse bias, it does not emit the light. And the operating voltage level will be 1.5 volt to 3.3 volt. And the response, if we see that is on and off switch, if you use LED as a device, that speed will be very high, that is of 1 nanosecond. Advantages of LED. Very low voltage and current is enough to operate the LED. The voltage ranges from 1 to 2 and current ranges from 5 to 20 milliamperes. These are the operating voltage and current. Total power output in LED is less than 150 milliwatts. That's also another advantage of LED. And response time is very less. That is within 10 nanoseconds itself response. That speed is high. Device does not need any heating or warm up time. Immediately switched on starts working. It's a meaning of no need of any heating and warm up time. And size is small, weight is also less. Strong in construction and can withstand shock and vibrations. And the lifetime of the LED, if we see, means that is more than 20 years. These are the advantages of LED. Next, we'll say the disadvantages of LED. If already explained, the operating voltage of LEDs ranges from 1.5 to 3.3 volt, even 3.6 volt. If excess voltage is given, that can damage the device, and similarly the current rating will be in the milliampere range. Excess current is given, in that case also that can damage the device. And the device is known to have much wider bandwidth compared to the laser diodes. Temperature depends on radiated power and wavelength. So it's a temperature dependent device. That's another disadvantage of the LED. Now we will see one of the application of the LED, that is 7-segment displays. Display devices provide a visual display of numbers, letters and various signs. These display devices can be classified as passive displays and active displays. Passive displays are light controllers. They are modulators of light in which the light pattern get modified on application of electric field. Example, we can say LCD. It won't produce light, it modifies the light for their working. Next, active displays. They are light emitters that generates lights. LEDs are used as low consumption indicator lamps. The 7-segment can display all numerals and 9 letters. Each segment contains LED which can be turned on or off to form the desired digit. Each segment of the array has to be switched in response to a logic signals. Now we'll see example of displaying number 2. in which segments A, B, D, E and G have been switched on and C and F remains off. Similarly, when all segments are on, digit formed is 8. If only the center segment G is off, the digit will be 0. Like that, we can display the numbers using LED in segment display. I hope you can understand about the LED. Thank you.